Namaste, welcome to my next tutorial, that is Earth tutorial. I'm Mohan Giri, and I will be explaining about the Monte-Carlo integration, its various aspects and how to integrate by using this method. So before moving to the code in Fortran, I would like to explain literally the theoretical part of Monte-Carlo integration. Okay, so actually Monte Carlo is a name of city. Okay, so let me show you on the textbook. Actually, it was a famous casino, Monte Carlo. So in casino, lots of gambling occurs. So everything is determined in casino by random or probabilities, random numbers. So Monte Carlo integration is also based on the random numbers generated in between any two points, that is within certain interval. The interval is divided into large number of random numbers without repeating those numbers, and we will find the integration in various ways. Okay, so first of all, Monte Carlo was introduced by Metropolis, and actually it was first used in the Manhattan project called Monte Carlo. Okay, so Monte Carlo simulation as well as Monte Carlo integration. Well, this is a function f of x, and okay, we have to find the integral of this function in between interval a and b. A is the lower limit of integration and b is the upper limit of integration. Well, so let me say you another thing as well. Monte Carlo integration is especially used to find the multidimensional integration, that is integration containing not only x as the variable but infinite or n number of variables. Okay, so the advantage of Monte Carlo is to integrate not only on a single variable but to many variables. Okay, so let me introduce the basic part of the integration. All right, and then yes. Okay, so theoretically, this is the average sum over f of x divided by n. This is the average of that function. So whenever average of that function is multiplied by difference of the interval, and that is the difference of the lower and upper limit of integration, then we can find the integration over limit a to b f of x dx. Okay, so so this is our formula, integration from a to b f of x dx. Well, this is our formula. Okay, we will discuss Fortran code later, but before that, let me further give introduction of Monte Carlo. Yes, actually Monte Carlo technique is based on the generation of random numbers. We can find Monte Carlo method helps to find the integration in multidimensional sequence. All right. Yes, this is about one introduction. Yes, so yes, actually I previously said this is the average of the function when multiplied by the difference of interval b minus a, then b minus a, then we can get the integration. Okay, this is for one dimension. We can extend the same integration in various intervals. For instance, if we have to integrate this function again from c to d dy, then again we will find the average of the function and into difference of interval in its variables. This is for x variable, and if we have integration this dy, then again we will multiply this answer by difference of interval d minus c. Okay, in this way we can extend one dimensional formula of Monte Carlo integration to many dimensional. Okay, so this is what we need to do. So okay, so Now let me talk about the random numbers. Well, so random numbers can be generated in between the two intervals in various ways. So out of that, I would like to explain one method. Okay, so to explain that method, let me open first terminal, Control Alt T, and then I will move to desktop because everything is over my desktop, and computation, and for YouTube. Okay, so this is my yes, this is the folder that where I want to generate random numbers. Let me open any document editor. Okay, so I will use Giri as my document editor. You can use gedit as well, but for this moment I will use Giri. Okay, name of the file will be random number.f90, just to put something name as here. Okay, so this is my Giri. Alright, so yes, how to generate random numbers in between any two intervals a and b, I will explain you. Okay, so this Fortran code has its intrinsic random numbers in the interval 0 to 1 only. Alright, so Fortran itself automatically generates numbers. So to generate that number, let me start the program. So this is the program, and I will name it as randoms. Okay, so yes, this is my format of the program. I need to generate n number of random numbers within the interval 0 to 1. We will use integer parameter, integer I. Okay, so yes, I need to use do loop. So I equals 1 2. I will generate 10,000, no, 1 lakh random numbers. So for that, let me define yux equals random of random number. This is the format of generating random number. Of course, random number lies between 0 to 1. This is the intrinsic limit. All right, so lower limit will be 1 and upper limit will be, sorry, lower limit will be 0 and upper limit will be 1, and we always generate random numbers between 0 to 1 as the intrinsic, but we can extend this to our desired limits. All right, so yes, this is the format of generating random numbers. But okay, so yux is a real parameter, so let me introduce it in here, real yux. Okay, so this is the random number. Now I have used do loop over here. So the format of do loop is to end after doing something, into. Okay, so this is the format of generating random numbers. If I want to print all random numbers from I equals 1 to 1 lakh, then I should print this yux inside the do loop as print yux. Okay, so if I want to print all the random numbers inside the do loop, then all the random numbers, then I should use print inside the do loop. Okay, so okay, if I want to okay, let it be. Let us run this program. Let us compile first. This is the compilation method. Okay, so let us run. See, these are the random numbers up to 1 lakh. See, here are 1 lakh random numbers, it in between 0 and 1. So yes, this is what we can do with random numbers. So generation of random number is really important while using Monte-Carlo simulation. That's why I gave tutorials first about random numbers. All right, so let us extend this concept first. We want to know the random numbers between 5 to 10, not between 0 to 1. In that case, what we can do, okay, so for that I will show you. So simply okay, so 5 to 10. All right, in between interval okay, let me define this as A, as we can generalize this always B. Okay, this can be written as, see, simply A plus, sorry, plus wait a minute, let P equals random number means okay, this P means the random numbers in between 0 to 1. Alright, but we have to extend this between A to B. Then in that case, first this is a random number, that means it lies between 0 to 1. Okay, we want to move this 0 to A and 1 to B. So idea is simple. First add, okay, in here you can add A. So after adding A, not only in here but also in A will be added in here as well. So this whole is the random numbers. So let us denote that by P. If I add A on P, I will get A plus P plus 1. Okay, sorry, here A and here A plus 1. Okay, because this is P. So substitute value of 0 and 1 here. I can get as A comma A plus 1. Okay, but I need B also. So this gives A comma A plus 1. That means this gives okay, no, do not write this. Okay, again, now we want to change this interval 1 to P. So for that, let us multiply this P by yes, we have A plus 1 more here, but we need P here. So 1 here, sorry, it's not P. If we get well, let me show you by, and this gives first A will be added to P. This gives yes, here we will have A and here we will have A plus 1. So answer is A comma A plus 1. Okay, so this is our answer. Now are you clear? But we need P here. So for that, to make this as P, what we can do is plus. Okay, let me do this in the next. Okay, now to change it into 1, we will multiply P by yes, A plus 1 should be removed and P should be B should be added. So what we do is B should be multiplied and A minus 1 should A plus 1 should be removed. So this ultimately gives P means 0 comma 1 multiplied by B minus A minus 1 gives, first into 0 gives 0 comma 1 into this P means 1 into B minus A minus 1 gives B minus A minus 1. Okay, so these are the two pairs. So see, if we added these two quantities, then what we get? Okay, let us add two conditions. Then we will have A plus 0 comma A plus 1 plus B minus A minus 1. So simply this is the what addition of ordered pair, and this should be equal to what A minus 1 and A plus 1 will be cancelled. So ultimately we will get ordered pair A comma B. So are you clear now? So to yes, this is 0 comma 1. We want to extend this interval into a comma b, then the process should be, let us suppose interval random numbers between a to b is y, and that is equal to, as I previously said, a plus x plus, what should I do, p, I mean this is x, no problem, yes, again x into b minus a minus 1. Simplifying this gives again same thing that I said earlier. Okay, so I have introduced y as our new variable here, that's why it should be real. So let us introduce y here. Now again let us okay, we can print here as y, and let us move from here to here, and yes, we can get x as well as y. Okay, so let us run the program. Warning, a may be used in this function. Okay, so a and b are not defined here. First we have to define a and b. Okay, for that a and b should be real number. Okay, so let us give input as a and b. Okay, this will provide input for a, and again this will provide input for lower limit. Alright, so this is what we want to do. We will substitute value of a and b as lower and upper limit of integration, and this formula will calculate the random numbers in between interval a and b. Let us see. Okay, first lower limit, we want to find numbers between 5 to 10. So this is what we wanted to see. Simply these are the random numbers in between 5 to 10. Okay, 10 means number less than 10, right? Because this is the open interval, not the closed one. Alright, so these are the numbers between 0 to 1. These are the numbers between 5 to 10. Alright, so this is how we can play with the random numbers. Now this concept will be useful while doing Monte-Carlo integration. Okay, so finally yes, this is our formula. A and b are lower and upper limit of integration, and this should be the function. Function should be added, and it should be divided by n to get average value of function, multiplied by difference of interval gives integration of that function. Okay, so let us begin our Fortran code. Yes, you know that to generate any file we can say Giri. The name of the program will be Monte-Carlo integration, mcint dot format should be f90. You know well about it. Yes, so alright, sorry, I already have file named this. Let me edit that. Monte-Carlo integration 1. Okay, so this is a file that I want to open. So as I previously said, let us build the program. The name should be Monte-Carlo integration. Yes, this is the format of the program. I would like to define function first. So defining function, you already know this. Okay, so the function is only the function of x. This is the format of the defining function, And let me define function as yux square, a very simple function, because you know well about this, and integration of this will be yux cube divided by 3, and we can simply check our answer easily. Alright, okay, I have used yux here, but x is not defined, so let us define yux as real variable. Alright, so this is a format of the function, and while calling this function inside the program, you will know that okay, implicit none should be used before doing anything, because this stops recognizing its intrinsic codes. Okay, so to call this function inside the program, we need to insert real external. Okay, name of the function is nothing but ef. Alright, so this is our fundamental program. Now we would like to give inputs as our lower and upper limit of integration. We would like to give inputs of n as the number of random numbers that we want to generate. So let us work on that first. So first we will give input of lower and upper limit of integration. Alright, so okay, let us define the format, you know, of print. Please insert the lower of integration. Alright, this is the format of print, and computer will read as a. Alright, I have not defined a, whether it's real or integer, so first define this as integer. Sorry, no, a should be real, because lower limit would be any numbers, either integer or real. Alright, so this is lower limit of integration. Similarly, let us input, please insert okay, this is the format of the print. Computer will read this as b, as the upper limit of integration. B is also real, so I defined b as real. Okay, again we want to give the input of n as the number of random numbers that we want to generate. So n would be integer. That's why let us define n as our integer. Okay, again let us give the input, please insert the number of random num that you want to generate. Okay, this is the format of the print, and computer will read as n. Make sure that this is the statistical method to find the integration of the function. So any statistical method assumes that the number of data should be as much layers as possible. So use value of n as much as possible. Right, as much as you can. So we give input a, b, and n. We define function as previously I said. This is the formula of the function. So first let us generate random numbers, and let us find a function of that random number, and then only we can do other things. Alright, so to generate random numbers, we need to define do loop. Okay, so define do. I runs from 1 to n. Okay, and this is the format of the do. Alright, so inside do loop we can do whatever we like. We can sum as well as, okay, so I is the integer, and I should define that I as the integer. Okay, so I should be written here. So first we want to find the random numbers in between a to b, not between 0 to 1. So let us further define another integer p as real parameter, and that p would be the a random number between 0 to 1. Okay, as I previously showed you that to find random numbers in between interval a to b, what we gonna do is, first of all, we add these two numbers. Okay, so first would be a comma a plus 1 is nothing but a plus p, and second would be p into b minus a minus 1, and then we will add up these two to find the numbers between a comma b. All right, yes, that is what we want to do. So for that, okay, x would be what? And random numbers between a to b. So to do that, a plus p plus p into b minus a minus 1. This is what we want to do. This gives the random number between the interval a comma b, and not between 0 comma 1. Okay, this is what we want to do. Okay, this is x, and what we're gonna do, simply was this formula. We will find function and then add up all those functions between 1 to n. All right, so let us do that. You know well how to sum. So outside the do loop, let us define sum equals 0 first, because okay, at first value sum should be 0. So to do sum of anything, we will do sum equals sum plus yes, what are we gonna do? Function. Okay, yes, so this should be function. All right, this is what we are doing. See how it works. First value of sum is 0, so I equals 1 means first value 0 plus f of first random number gives sum. Now the resulted answer will act as sum for the I equals 2, and that sum plus f of second random number gives the second sum. Alright, so in this way summation f of x is calculated. This is the format of calculating summation f of x from 1 to n. So yes, this is what you need to understand. Sum is introduced in here. This is the real variable, so let me introduce that in here as well. Actually, this is the definition of sum as real. All right, so we calculated, see, sum over f of x from 1 to n is calculated. Now we multiply that sum by this number and we can get the integration. Simple. So if we want to get answer in each random numbers, then we should find inside the do loop. If we want to find answer, only one answer within a short interval of time, then we will do outside the do loop. Alright, so okay, sorry, do is left here. So I want to find the answer, only one answer, and not in every random number. So that's why I am finding answer right here. So I define integration, int only as, okay, I can define integration, there is no problem. Integration equals, yes, of course, sum means sum over f of x from 1 to n into b minus a divided by n. Okay, that's what our formula is. So first b minus a into sum upon n. So this is the formula, there is no problem. All right, I introduced integration here. Let me define that integration as the real, real. So yes, I need to define integration as the real parameter. This is our integration, and let us print on our this on our answer. Right, yes, this is the format of print, the integrated value value is. This is the format of the print, and we will print integration. All right, because this is our answer. So yes, this is the Monte Carlo integration. Very simple, very simple. We can integrate in between limit a and b by using this method. This is one-dimensional Monte Carlo integration. In the next video I will be talking about many dimensional Monte Carlo integration, but here this is the one-dimensional integration. Okay, so I want to first show you whether this works or not. Symbol x has no implicit type. Oh, I have not defined x as real inside the program. I defined that within the function, but not right inside the program. Okay, now it will work. Yes, so let us build this and run. Okay, what is the lower limit? You know that our function is x square. We know our answer. So x square gives x cube divided by 3. X cube divided by 3 means you know. Okay, after limit would be 5, lower limit would be 5 and upper limit would be 10, and insert the number of random number that you want to generate. Okay, I want to generate 1 lakh random numbers. This is 10,000, 1 lakh. Okay, so the answer is integrated value is 291.755. okay, let us check that whether that's right or not. So in between the limit 5 to 10, let me open calculator first. You know, x cube divided by 3 in between 5 to 10 means 10 to the power cube minus 5 to the power cube divided by 3, right? That means 10 to the power cube means 1000 minus 5 to the power cube means 125 divided by 3 gives answer as 291.66. What is the right answer? 291.75. so answer is almost correct. So if we can generate random numbers more than 1 lakh, then answer would be more correct. So okay, let us calculate error within the Fortran code. So for that, let us define a real answer. So let me define answer as real, and then here answer ANSWER, answer equals x cube divided by 3 means x cube divided by 3 in the range a to b means 5 to the power cube to 10 to the power cube, means it's very simple. Answer is a to the power cube, sorry, b to the power cube minus a to the power cube divided by 3. Alright, so b to the power cube minus a to the power cube divided by 3. So this is our real answer. Let us print the integrated value using Monte Carlo and manually respectively is. So this is the integration means Monte Carlo, and this is manually. All right, so this is this will show the real answer as well as answer obtained from Monte Carlo. Let us check it on what it gives. Okay, lower limit is 5 and upper limit is 10, and number that I want to generate. Previously I generated 1 lakh, right? I will generate 2 lakh, sorry, 10 lakh now. 10,000 lakh, 10 lakh. All right, yes. So using Monte Carlo method is 291.68, and using manually is 291.66. see, I previously I used 1 lakh random numbers. Now I am using 10 lakh random numbers. So answer is very near, again let us calculate percentage error as well. So let me define error equals, you know how to calculate error, absolute value of integration minus answer or answer minus integration, whatever it is. It both gives same value while subtracting and taking the absolute value. So I can write anything, and answer minus integration absolute value over to find percentage. Okay, first of all multiply this by 100 over, we will compare this by our real answer, and that is answer by using manually. Alright, so this is the error. First of all find error, then only print. Okay, so that's why yes, we should insert here. Alright, this is the answer, and error is the percentage error is error. Okay, so I have not defined error whether it's real or integer, so let me define error in here as well. Okay, yes, this is the completion of our program. Let us again check that. We want to find the integration between 5 to 10, so lower limit is 5, upper limit is 10. Random numbers, previously I generated 10 lakh, now I will generate 1 crore random numbers. For 5, 6, this is 10 lakh, 1 crore. So answer is to this one 292.069 and 291.666656. so this is the percentage error. That means our answer is slightly greater. So okay, in 1 crore answer is slightly only 0.13% error occurred. Let us check in 10 lakh. So while checking in 10 lakh, lower limit is 5, upper limit is 10. Number is 10 lakh and the answer is this, and error is very less. So 0.0004% is absolutely less error. Okay, so this is how we can reduce the errors while integrating, and of course so we need to be conscious while using the value of yan, that means numbers that random numbers that we want to generate. And this is how we can integrate by using Monte Carlo integration. Thank you so much for watching this video. Please do comment and do curse on this activity whether you like or not.